Hello students, in this video we are going to start with this topic of functions which is for grade 11. The course name is MCR3U. So the chapter name is functions. So in this video we will be looking at what is a function. Okay, so for defining a function we should know first that suppose you are given two sets. So I have a set here. This is my set 1, 2, 3. It contains three elements 1, 2 and 3. And then I have another set here which contains three elements A, B and C. Right, and then we have something called relation. So we will first look at what do we mean by a relation, and then we will put some conditions on the relation to make it a function. So see, what I can do is I can relate elements of this set. Let me call this set as A and this set as B. So I am relating elements of set A with the elements of set B. So I have elements of set B here, A, B and C. For example, what I can do is I can relate 1 with A, 1 with B, 1 with C, or I can relate 2 with A, 2 with B, 2 with C, or I can relate 3 with A, 3 with B and 3 with C. So these are the all possible pairs. So here I have made these pairs. Pairs means the first element is telling us the element from set A which is related to the second element from set B. So this is the set of all possible pairs. Now you take any subset. I can take the whole set also, but you can take any subset. For example, if I take this set only 1A, 1B, 1C. So this is a relation. This is a relation from set A to B. So how this relation looks like? So I have a relation like this. That's 1 is related to A, 1 is related to B and 1 is related to C. Okay, so this is one relation. I can have some another set. For example, I can choose this element and say this element. So I have this one 1A, 2A and 2C. Here also this is also a relation. So how this relation looks like? So you have 1, 2, 3 and you have A, B, C. So here you see 1 is related to A, 2 is related to A and then 2 is related to C. Okay, so relation is any subset. Like this is a set of ordered pairs. I have written the definition here. So a relation is a set of ordered pairs, values of the independent variables. So this first set we call them as independent variables. Are paired with the values of the dependent variable. So there is no restriction. The only thing is you have to take a subset of this whole set. Okay, so this is a relation. So there is, you are free to choose any ordered pair. So that is a relation. Fine. For example, if I ask you, is this the relation 1A? Only this element. Yes, this is also a relation. How this relation looks like? So you have 1, 2, 3 and then you have A, B, C. So 1 is related to A. So this is how the relation looks like. Right. Now to make relation a function, we have some conditions. So what are the conditions? So conditions for making a relation into a function. So the main thing is that this is your domain set. We call this as domain set and we call it as range set. Okay, so we say that for each independent variable that will be from your range set, there should be only one dependent variable. Okay, so for example, if I take this 1, 2, 3 and I have A, B, C and this 1 is related to A, 2 is related to B, 3 is related to C. So here you see for each independent variable, I have only one dependent variable. For 1 I have a, for 2 I have b, and for 3 I have c. So this is a function. This is a function. So I can write it like this: 1a, 2b, 3c. Okay, so we can have written the definition here, that a relation where each value of the independent variable corresponds with only one value of the dependent variable. That is a function, right? Okay, so what we can do is, we can look at more examples. If I give you 1, 2, 3, and then I give you a, b, c here, and I give you like this: 1 is going to a, 2 is going to b, and 3 is going to b. Is it a function? So this is a function. The first one is a function. Yes. Now the second one, is it a function? So you see, for one independent variable, see, this is independent variable, I have only one dependent variable. 2 is an independent variable, and corresponding to 2, only b is the dependent variable. And corresponding to 3, only b is the dependent variable. So we can have that for the two values of x, we have the same dependent variable, but the condition that for each element which is in the domain set, there should be only one element in the range set. That is true. So here I can write it as 1a, 2b, 3b. So yes, this is a function. Yes, this is a function, because the condition that each independent variable have only one corresponding dependent variable, that is true, right? So we can look at more examples. For example, I can give you this one: 1, 2, 3, and then you have a, b, c. So you have 1 is going to a, 2 is going to b, 2 is going to c, and 3 is going to b. So here you see, corresponding to this one, you have only one dependent variable a, and corresponding to this 3, you have only one dependent variable, which is b, and corresponding to this 2, you have two dependent variables, which is b and c. So this is not a function. So you have like this: 1a, 2b, 2c, and 3b. So you see, corresponding to 1, you have only one dependent variable, that is a, and corresponding to 3, you have only one dependent variable, that is b. But corresponding to 2, you have b also, and you have c also. So this is not a function. So not a function. And one more thing, we generally don't write it in the conditions if you look in the books. Also, for example, in relations, here these elements were unassociated. Okay, here only one was associated. But in function, we make that all the elements of the domain set should be associated. So what we do, we can always make the domain shorter if some of the element is not associated. So that is how we proceed. That is why we don't write it. So it means that if we graphically look at these conditions, so it means that if I draw, like, this is my independent variables here, these are my independent variables, and there are my dependent variables. So what I am saying is that corresponding to one value, okay, so suppose you have one value here, this is your independent variable. You can have only one dependent variable. You cannot have, if you have, like, for example, in this case, corresponding, this is 1, this is 2, this is 3. Corresponding to 1, we have a, right? So suppose this is a, this is b, and this is c. And corresponding to 2, we have b also and c also. So corresponding to 2, there are two dependent variables. Can you see this one and this one? So this is not a function. So function means corresponding to one independent variable, we should have only one dependent variable. Okay, so let us look at one example here. So we have here, you can see the ages and the soccer practice days of 4 students. So you have 4 students, and their age and their soccer practice days, they are listed. For example, for Craig, he is 15 years old, and he does like soccer practice on Tuesdays. And then Magda is 16 years on Tuesdays, Stephanie 15 years on Thursdays, and Amit 17 years and on Saturdays, right? So now the question is, for each of the given relations, So you are given two relations, student and days of the soccer practice, and then age and the day of the soccer practice. So we have to state the domain and the range, and then determine whether or not the relations are functions. So let us do for the first one. So your first one here is students and days for the soccer practice. Students and days for the soccer practice. So here you see. So if I have the student here. So I have Craig, and then I have Magda, and then I have Stephanie, and then I have Amit. And then you have your practice days. They are Tuesdays, and then you have Tuesday, and then you have Thursday. So let me write Tuesday only once. So you have Thursday and Saturday. Right, so we have, so the relation looks like that. Craig is on Tuesdays, Magda is on Tuesdays, Stephanie is on Thursday, and Amit is on Saturday. Right, so the question asked is we have to tell the domain and range. So we write it here that domain is name of all the students. So we write it like this. So you make a curly bracket, and then you have Craig, and then you have Magda, and then you have Stephanie, and then you have Amit, and then you close the braces. And then your range here is this Tuesdays, Thursdays, and Saturday. So Tuesday, Thursdays, and Saturdays. So what is the domain? Domain is basically all the independent variables, right? Set of all the independent variables. And range is basically set of all the dependent variables. So basically where your function is taking you, that is your range. And domain is from where you are going, that is your domain, right? So we can write it like this, that domain is from where you are going, right? So it can be for a function or for a relation, from where you are going, right? So, or you can say your set of all independent variables. And what is your range? Range is where your function is taking you, where your function is taking you. So that is set of all dependent variables, set of all dependent variables. Okay, so here the question was you have to find the domain and the range. That we did it. And now the question is whether it is a relation, whether this relation is a function or not. Now we can think of, see here, corresponding to the first independent variable Craig, we have only one dependent variable, that is Tuesdays. Corresponding to Magda, we have only one dependent variable, that is Tuesdays again. And corresponding to Stephanie, we have one dependent variable, that is Thursdays. And corresponding to Amit, we have one dependent variable, that is Saturdays. So it means that just looking at the name of the student, you know, right, that which one is the day, right? If I ask you for Craig, it's Tuesday. For Magda, it's Tuesday. For Stephanie, it's Thursday. For Amit, it's Saturday. So you are nowhere in dilemma. You don't have any uncertainty anywhere. So this is a function, right? So we can write it like this, that the function is, this is one way of representing your function, one way of representation we can write. And another way is that you can write the order pairs. For example, I can write Craig and Tuesday, and then I have Magda and Tuesday, and then I have Stephanie and Thursday, and then I have Amit and Saturday, right? So this is how this is a second way of representing your function, second way of representing the function, right? And so the answer is, because corresponding to each independent variable we have only one dependent variable, so the answer is yes, it is a function. It is a function. Okay. Now look at the second one. Second one is age and the day of the soccer practice. So age here is 15, 16, 15, 17. Right. So you have age and the day for the soccer practice. So can you take a minute and think about, like, is it a function or not? So first of all, we will see how it looks like, right? So we have age. So you have age here for B part. You have age. Age is 15. We can see 15, 16 and 17. And then you have days here. They are Saturday, Thursdays and you have Tuesdays. So we have Tuesdays, Saturday, Thursdays, and you have Saturdays. So if we look at for Craig, he's 15 and he goes on Tuesdays. So we have for Craig it's Tuesdays, and then Magda 16 and it's again Tuesday, and for Stephanie she's 15 and it's Thursdays. So it's like this, and then Amit is 17 and it is Saturday. Now you see, so what is the domain? Domain here is set of independent variables, that is 15, 16 and 17. And what is the range? Range here is your Tuesdays, Thursdays and Saturdays. Right. So now you see, now we have to see whether it is a relation or not. So let me tell you, this is one way of representation. Second representation can be like this, that you are writing 15 with Tuesdays, then you have 15 with Thursday, and then you have 16 with Tuesdays, and then you have 17 with Saturday. So that is another way of representing the function or relation. Now is it a function? So here you see, corresponding to 15 you have two dependent variables, Tuesday as well as Thursdays. So this is not a function. So here you see, corresponding to the independent variable 15, we have two dependent variables. Which are Tuesdays and Thursday. So it is not a function. Not a function. So this is how we check, right, whether it is a function or not. So we have something called, so till now I hope you should be able to understand the difference between a relation and a function. So take away from here, from this much video, the takeaway is you should be comfortable with relation, what is a relation, and then how a relation becomes a function, how you test it, whether it is a function or not, and some little bit of domain and range. And over the time, when we will practice more and more problems, you will be more comfortable with these things. Okay. So now, so I have further I have put some practice questions, and I will tell you a test also. So here you see, determine which of the following graphs are functions. Okay. So here you see, if I ask you, so this is your independent variable, right? Here is your independent variable, and this y-axis is your dependent variable. So here you see, here if this is the independent variable, you can see corresponding to this independent variable, this is also the dependent variable and this is also the dependent variable. So corresponding to this independent variable, we have two dependent variables. So this is not a function. So we have something called vertical line test. So whenever we are given the graphs, so we have vertical line test, where we say that if we draw a vertical line, and if anywhere on the graph the vertical line cuts our graph at 2 points, and it is happening everywhere for this particular graph. Okay, so what is vertical line test? So this test is, if you draw vertical lines and any one of the vertical line, at least any one of the vertical line cuts the graph at more than one point. So it can be 3 also. Then it is not a function. Then it is not a function. And if every vertical line cuts the graph at exactly one point, then it is a function. For example, if I look at here you see, if you draw vertical lines exactly, it is intersecting at one point because your graph is this green line. Okay, so this is a function. Yes, it is a function. In the last case, we will write it like, no, it is not a function. And if I ask you here, what is your domain? So you see, domain is our set of independent variables. And here you see, we are going from -3 to +3. Okay, so domain is set of independent variables. So here we are going from -3. So we write it like this, -3 less than x less than 3. So another way of writing this is x such that x is between -3 and 3. And range is the dependent variable range. So you have to see this one, how height of your function. So here you see you are going from 0 to 3. So the range is 0 less than y less than 3. So you have to understand x is for your independent variable. So for domain you will use x, and y is for your dependent variable. So range you will use y. So you can also write it as this, y such that 0 less than y less than 3. So this is your range. Now here is another one. So you have to tell whether it is a function or not. So again you can use the vertical line test. Here you see, if I draw vertical lines, so every vertical line is intersecting my graph only once. So every vertical line is intersecting the graph only at once. Therefore, it is a function. And regarding the domain of the function, so your domain is, you see here, the set of all x values. So here, because your graph is, going like this, further and further. So whole x-axis is covered. So we write it like the domain is double, you make double line R. It means the set of all real numbers. So you can write it like this, x such that x belongs to real numbers. So this is your domain. And what is the range? Range, you see, so your graph is nowhere above here, above 3. So your graph starts from 3 and it's going all the way to infinity, minus infinity. So you can write it like this, minus infinity less than y less than is equal to 3. Or you can write it like this, y such that y is greater than equal to 3. So understood that it is, less than is equal to 3. Y is less than is equal to 3. Okay? So it's how we look at whether a given graph is a function or not. So you should be comfortable with this vertical line test. This is what you are going to use again and again. So thank you for watching. And if you have any comments or if you have any queries, you can write in the comment box. And you can also write us an email if you have any doubts or any problems, right? And you want to contact, so you can write us an email at nochalkacademy@gmail.com. So your comments are always welcome. So this is where you can write us anything you would like to. Thank you so much. Happy learning.